Because the innovation is that our HPC environment only runs Linux.
Correct.
Not Windows.
Yeah.
That's the issue.
Okay. And
But
then,
better than the rest of the platforms are we.
okay.
That's
And how
probably
about,
gonna be the case for most shops now that have swallowed Petrel.
oh, they had, yeah, because, okay,
Yeah.
they're not landmark. How about Oxy?
HPC is Linux, but we can also have some Windows.
Okay. So I'm going to assign, well, I'll ask both Ramses and Georgianis. When you go back home and you're on your HPC, does the AASPI main GUI, it'll come up, but can you plot the VDS file?
I can try it out.
You'd have to log in from, oh, okay, yeah, let us know. Because with our shop, we don't have, what is it, where'd David go? We don't have what, the GPUs, or what is it that we're missing? Oh, no, we don't have the graphics library, OpenGL.
OpenGL.
We don't have OpenGL on our Linux machines. So therefore, things just like crawl. And I don't know, so your job then, is, do you have OpenGL on your
I'll double check.
HPCs? And then you can ask, is it hard to put it on there? I don't know. I know the folks who have
License.
desktop Linux, everything works great. It's the HPC.
Well, often they won't put it on there because there's no graphics card. but-
Because there's, yeah, and there's no graphics card, right? We don't have a graphics card.
Yeah.
So, like what's that in? So, as we move to the VTK and some of the fancier interfaces in the Linux environment, be kind of nice to do that. Be kind of nice to do that. Okay, so you got me up?
Yes. There.
Okay, so I'm gonna do well, 2 things, maybe 3 things. David asked me to talk about the rewrite of the Linux interface, which I rewrote. Okay, so what happened? What's happened for those of you who go back and forth between Windows and Linux? You've noticed we had the old Linux environment where we started the user interface, AASPI util. And then about 1.5 years ago, David and Tong Ha rewrote the interface with the VDS in mind and more logical, okay? So in October, November, I said, all right, I'm gonna make all of our Linux interface look as close to the Windows interface as possible. But then, of course, being me, I said, he should have done this, he should have done that. We argued for 2 years about what the word machine learn. I like the word shallow learning. And he says, no, that's not going to market. Don't use the word shallow learning versus deep learning. He won that argument, okay? So we call it now attribute-driven machine learning, okay? Or multi-attribute machine learning. So then I rewrote all that, and guess what? After I rewrote that, then he had to rewrite the Windows one. But today they look the same, okay?
Yeah.
So I'll go through what the layout is for that and for the pre-stack utilities too, where we don't have a Windows interface. But let me start with this. This is real simple. Oh, as Nora showed the other day, I had eyeball surgery, with the cataracts. You will all have that if you live as long as I have. It's not painful at all, but it's a month or 2 of stumbling into stuff and having glasses that you need near, and you walk into things. So I'll have difficulty here. Anyhow, I have this little presentation. I didn't print it out. We'll just email it, okay? Or you're going to put it on the web. Okay, so here is the, thank you. Here's the motivation. This is a picture from Marcos Mas, a Brasileiro did his PhD last year. He's back in Brazil now at Petrobras. And he did SOM clustering and then the decision tree clustering as well. And his faces were reinforced, thank you, His facies were not, well, for the initial ones, they were geologic facies, but the engineers don't care about geology. They don't care whether the rock is pink or whatever. They want to know which areas are producing. So what he did is he started out with the basically the production. So the FC and Alexandra, FC stands for flow capacity, right? Okay. Okay, thank you. I had forgotten. Okay. So he's got in this one, he's got an arbitrary line through Mero Field, I think. And all the fields are named after fish for some reason. Ask me why. So here is his facies from SOM. But then for, let's say, this well C, he's got an area that's 2,000 millidarcy meters, 1,000 millidarcy meters, 44,000 millidarcy meters. So he has high permeability, low permeability. And then here is his SOM model showing more geology. So it's a posteriori interpretation. So you do the clustering first. Now choose the attributes, you're prejudicing, etc. But then with the well control, he can say, the purple is karsted, and the red or the pink are igneous, and then the cyan are platform facies, etc. And in there, he's using geomorphology as well, obviously. Okay, so you got a geologic model, and this is how unsupervised learning works in general. Okay, and then he's got appraisal candidates. Here is where all his wells are, and then they haven't done anything, so they're high grading them. Now, if you remember from last year when he talked about this, the issue they have, they don't have many shear logs, or any, they maybe have no shear logs. And so they can't do the cool rock physics stuff within a timely basis. So that he feels like it's 5 years till they get enough data to do a good quantitative interpretation. So what can you do now while you got your drilling boat out there? Okay, so here is where he went then, and what is initiated the work I'll show you here now. The data happen to be pre-stacked depth migrated. They're good quality data. He took the wells, and then the hard way, using spreadsheets and whatever, he extracted voxels, a 3x3, around vertical wells, okay? And then this became training data. So the training data were the different flow units, okay? Really good production, and then mediocre production and no production, okay? So that's the kind of facies that many of you are interested in. And here is the kind of things the hyper producers, this area, this is what they want to drill first. And then these are good producers, and the geology, from those of you who may have read his papers, they're published papers. They're Heather has them posted, most of them on our website. Definitely it's in his dissertation. It's a lot of hydrothermally altered dolomite. Okay, so hot fluids coming in, karstifying. So it's a pretty cool paper. So what they want to do is find out the areas with the high flow capacity. And then in this case, he uses a random forest decision tree, the software that David has packaged up, and that training data from the wells to show where is the hyperflow, which are these kind of purple features, okay? So that's kind of where we want to go. We want everything to be like Marcus did, but not have the patience and the time that Marcus was able to spend doing it, okay? So I thought, okay, if you read the newspapers, machine learning is going to get rid of everybody's job. If you look at our software, it's oh my God, where do you even start? It is really complicated. And you've seen little steps yesterday. The one who went all the way through was Hilmi. Okay, there's Hilmi. Notice I can't see people, all right? So there's Hilmi back there. I think he did a great job of showing the flow. So what I put together is a flow chart, okay? And this will be in all of our documentation in the not too distant future. So here is where we have started, let's say as of, oh, we've been doing this for 3 years or so, but the software you've used up till now. You start out with a seismic or attribute volume, okay, whatever you like. And then you define polygons, like, oh, I think this is a mass transport complex. I'm thinking of GA here now. I think this is a mass transport complex, and I think this is salt, diapir, and I think these are conformal sediments, and I think this is maybe a channel. So the human interpreter picks different facies, and then the software is going to be as good or as bad as GA. Okay, you're training it to replicate the human interpreter. Okay, so what you have is different polygons, facies 1, facies 2, facies n. So you might have n polygons and m facies. You might have 6 facies and 20 polygons. Polygons can be on time slices, horizon slices, vertical slices, etc. The next step in our software is to convert polygons to points. So what this does, it takes the polygons, looks inside, finds out all the values. Here's the XYZ location, actually inline crossline and time, or inline crossline and depth. Okay, so those are the point sets. And earlier when Anik was showing his blue thing, that could be a polygon. Okay, that'd be kind of like an easy way to, because polygons take a lot of patience. You know, when you have a channel, it's hard to get things to fit in the damn polygon. So that's kind of cool. All right, so there's other ways of doing it. Then these give you training data sets, one for each facies, or in Marcus's example, one for each flow capacity unit, or for Georgiani's or any of you working unconventionals, which is at least half of you, if you had your XYZs of stages and you had a metric of interest, how much proppant per stage, okay? What's the breakdown pressure at each stage? Or certainly for the well, what's the production per well? Maybe initial production per stage, depending on how sophisticated your engineers are. You can think of, okay, let's bracket that too. You know, low, medium, high, or 0 to 100, you know, 0 to 1 train car, 1 to 4 train cars, 4 to 8 train cars, however you measure proppant, okay? And then that becomes our facies, okay? So this is the part we need to get into all this, and we're not far away from it. The hard part is the darn user interface and the darn formats, which are all over the place. Okay, so here we are. Then we got these. Then there's a generating. Here's our training data. Whew. Now, oh, and you have candidate at, you have, I went backwards, sorry. You have candidate attributes. And even the unsupervised, we're going to have our favorite attributes or attributes we think are sensitive to things of interest. So again, talking to Georgiani, she's interested in karst again. And well, okay, yeah, so structural lows, low frequency response, kind of a random texture, so high entropy. So there's a bunch, you could think of half a dozen things for your data set that you would be as a candidate. Okay, so yesterday, Hilmi talked about this stage, analyze input. His training data were the way we started 10 years ago. Might have been longer than 10 years ago. 12 years ago, okay? When we did our first SOM. We just picked points on a grid, every 10th in line, cross line, vertical. That was our training data. And that's what Hilmi showed yesterday. That would be truly unsupervised. If the training data is driven by polygons, by well control, by Hilmi's SAM, you're really prejudicing it so it's semi-supervised. you're driving the software to answer questions of which you're interested in the answer, okay? And then the choice of attributes is adding supervision as well. Okay, so here you go, try different things, and then you create a final model. Then you're going to run it. So how do you try different things? Well, Hilmi's example yesterday was very clear. He said, okay, I'm doing Gaussian mixtures. Which ones, how many attributes do I use? I don't think you addressed which attributes, right? Not yet, okay, and we were talking about that on the board before. If you go look at the poster downstairs from our, there you are, okay. Your poster on PCA, he's using a technique, and we argue, where's David? We argue about name. So we're calling it global PCA. I think it's local PCA. So when we do all this data scaling, now we got arguments about everything. And, you know, I got Chopra, he wants me to write another book when you guys are writing a book. You got to get this straight. There's a lot of chaff out there. So you see here we have this scaling thing. So I think everybody realizes that attributes have all kind of crazy units. Coherence goes 0 to 1. Amplitude goes from minus 25,000 to plus 25,000, you know. Curvature goes maybe minus 2 to plus 2, depending on the units. So the first thing you need to do is remove the units using a z-score, common. And then if you got things that are biased, you may want to do a log that has a log normal distribution. Certain algorithms that are Gaussian based, SOM, GTM, PCA, GMM, they're going to be prejudiced to like Gaussian distributions, unless you want to look at outliers. Outliers would be edges, those kind of things. Then you got to scratch your head. Okay, so you got all of that. That's the scaling. So we got a whole thing with scale. Hyperparameters is a 25-cent word. The hyperparameters yesterday were 7 and 1,000, right, Hilmi? So just remember those two numbers. That's your hyperparameter of choice. Now, you know, how many attributes you're going to have, how many iterations, that kind of stuff. So you hunt and peck, okay? For his algorithm, for random forests, the evaluation of how many or which attributes to use is using these shapely something explanations, okay? Things, okay? That's pretty cool. I have here maybe this one here, which you can, we haven't done it now. So this is work that GA did 10 years ago, 8 years ago for GTM, and that the geophysical insights people do for SOM, because they've got Gaussians. So you kind of compare one Gaussian for facies 1 to Gaussian of facies 2. And, oh, I want them to be as different as possible. Which attributes do I choose to make those distributions not overlap? Okay. We have that now with some software that GA wrote. It's too complicated for a normal person to use. We're going to break it out and put it in this analysis thing. First for GTM, we'll do that in probably 2 months. Everything else is there. And then later for SOM. Okay, so we had the analyze input. We create our final model. We get our creator and final model. We might do cluster analysis in the case of k-means, GMM. Then we have a sensitivity analysis, probability to different clusters, optimum attributes, most likely cluster, and the probability. And like Hilmi showed, the probability of our not predicting a voxel at all. Okay. And then for the projection techniques like GTM and SOM, then we can do this Bhattacharya distances to how likely any particular voxel. So that gives you an overview of what we're doing. Okay, so here's today's objective. We want to generate a point sets about wells. Just a cartoon. I've got an oil sand here, a gas sand there. Let's say shale, limestone, another shale, wet sand, mudstone. I got different wells. I have depth. Okay, the wells aren't vertical and the stratigraphy is not horizontal. So the cases we've done up to date, the wells were vertical. Tao Zhao did one of these for down in Tampico. Okay, in the Sierra Madre Oriental. Okay, shale, clay, carbonate wash. And then Marcus did one. Okay, so here's Marcus's on the left. And here's basically what this algorithm does. It takes the well logs with measured depth, X, Y, Z, and then we need a facies log. So I've been talking to Georgia and he said, no, all you need is this. So I trust her. So I'm going to use the LAS log with facies, you know, where you have measured depth, relative XY. I hate that because I have to then have the real XYs, but another step. And then within that facies, I need the top and the bottom of the facies. You have the dip of the well, and you have the structural dip. So you're going to generate a cylinder that's oriented along that, and that's your points. Okay, so the concept's pretty simple when you draw a picture like this, all right? And so now here's how you're going to generate point sets about the wells. I'm going to go through it and then we'll just do it. It won't take long to do. So step 0, this is the part that we're not going to help you to do. You're going to have time horizons. And then if you're in a resource play, you're going to have hundreds, if not thousands of wells. And if you're in a developed field, you'll have maybe 15, 20 wells. And whatever you have, the engineers want everything in depth. So you're going to convert those horizons to depth, okay? And the common way to do it with Petrel, for instance, is with geostatistics. So you take your carefully picked horizons, and then you're going to take your time depth pairs for each horizon. It means you have to tie your wells. You know how to do that. And then you're going to do kriging with external drift. That's the formal name, and Petrel might give it a different name. Okay, so here's your workstation. Horizons in time, your time depth pairs, kriging with external drift, workstation format, horizons in depth. So I know all the guys in Devon, they do that. They have to do this. This is your product, okay? Then step 1 in our software, these horizons can be in all crazy different formats, you know, 4 or 5 of them. Anyhow, so you got to convert your workstation format horizons in time. They're text file. We need to convert them into AASPI format horizons. We'll do the same for the depth one. And the reason for that, otherwise our codes become, oh, and then we got to read this option, that option, the other option. Things get out of control quick. Then, and also we can display them. Then we need to convert our time domain seismic data to depth. So here's our horizons in time. Here's our horizons in depth, our seismic data in time, and we're just going to register the data. Okay, so if you have 4 or 5 horizons, you're just going to vertically stretch and squeeze these things to fall in between. So a real simple concept, but built on the work you do day in and day out, picking, you know, half a dozen horizons around your target. It's not going to refocus the data, but it's going to use all that well control that you use to generate your depth horizon. Okay, then step 3, we got to compute structural depth. We're going to use that depth volume now, push the buttons in AASPI, generate volumetric depth in the depth domain. That's going to give us the guide for these little cylinders. Okay, which direction?
You want something that can go to step 3 directly?
Step 3.
I just keep all the previous steps if you already have something that.
Oh, yeah, well, no. Because Corey migrated the data. And Corey didn't know about tilted VTI. So he's pretty damn close. He's a couple hundred meters in the proximity, but not good enough. You still have to tie your wells. So what you're going to do is you take your depth data, perfectly good depth data, no, and then you're going to use your well control and push it down to where you want. You're going to use kriging with external drift to get the horizons correct for you. So that answer, you got to fix it. the same program, will, if you are able to pick a P wave volume and a converted wave volume and pick the same horizon, that's tough. Because what's a peak in one may not be a peak in the other, but anyhow, if you do that, now you can convert your data to time. More important for you guys, again, when Jenny's here, she's got a folder at Oxy that says Marfurt's ideas will never work. Twisted in the folder. Okay. So if you have azimuthally sector data, a real common product for land data, and also like Petrobras, all their marine data, there's not, and no data real common. Well, you pick you're interested in amplitude variation with azimuth, AVAZ, but we have a little bit of residual amplitude variation, or velocity variation with depth. So what do? You pick your stack volume, you take those picks, put them onto the 0 degree one, and you have a 0 degree horizon, and then a 30 degree horizon, and a 60 degree horizon, and then you register them all again so that everything's lined up and you can do AV interface. So the same concept works for a lot of time-lapse seismic too. Works for the same thing there. Okay. So then here's your inline dip, cross-line dip, well facies, define point sets, point set 1, point set facies 2, point set facies n, but the point sets may be amount of proppant of 1 train car point set, 2 to 4 train car point set, that kind of point set. Okay, so you be creative. Okay, so this is how it is. Now you can get in, and you're going to, Corey, you're going to try doing this. You're going to go into the utility. I happen to use the AASPI GUI utility, but they're going to look almost exactly the same. Yep, post-stack. You go to import, export, and you're going to drop down to surfaces. And I think I made it big enough so somebody like me could read it. Yes. Okay. And you're just going to import those surfaces. I think one of the guys did this. One of the guys did it yesterday. Okay, so you're going to pick that up. And in this GUI, you're going to have a couple of things. Yeah, I know we did this yesterday because we had this unknown. We're going to pick in the D_MIG Volve. Oh, we're in the Volve data set. Okay, so we're in day 2, Marfurt something.
There's a time depth.
Time depth, yeah. So the time volume is called Volve.
Yep.
And you're going to bring that into the first one. And the default here is Earth Vision. We'll skip that for the moment. And the input time, it's going to read it in as seconds because that's what's in the headers, the .h file. And you're not going to be able to change it. That's what it is. But our time data, you can change it now. Our horizons are going to be in milliseconds. And our output, we want them to be in seconds. So most everybody will have their seismic data volume in either seconds, kilometers, or kilofeet. That is 98%. Yeah, there's some research guys that show who are now in India, right? Who might have put them in meters or in feet. But those don't display well in most workstations and anything.
Most of the ones I saw were either milliseconds or feet or meters.
In vertical?
Yeah.
Yeah. Well, is that how it's labeled or is that how it's stored in SegWide? There's a difference because we store the time increment in microseconds.
Oh, yes.
And therefore, you're storing meters in millicubic feet.
Yeah.
Something really stupid.
Yeah.
Okay. Anyhow. All right. And then the vertical units of the output is going to be in seconds. It's going to generate an output directory. It's going to be called AASPI surfaces in seconds. Okay. Click OK. We'll go through it. Oh, we don't click OK yet. We got to worry about the horizons. We're going to go here and click browse and add to the current list. And I guess I should do that. Okay, so David, if I hit escape, if I minimize this, yeah, here. Okay, so I am in Import, export.
Let me just look at it.
Am I in the right spot?
No, you're good, yeah. Go
Oh,
up. Go all the way
okay.
down.
Great. Okay, I'm in import, export. I'm gonna go to surfaces and it'll be the top line, ASCII format. Gonna browse, bring in my day 2 ...
Number 2.
I'm in the wrong spot. Day 2.
You're in the right spot. This is time depth.
Oh, time to depth, thank you. Okay, so it's got that. And then it's saying, hey, you gotta define your vertical units. It's gonna be by default undefined, okay? Because you don't know what it is. So I want them to be in seconds. Okay. So I'm gonna put that in seconds. I'm just gonna put anything in here, January 30th, whatever. And then down here, I'm gonna do browse and add to current list. I'm gonna go, these data were, I'm in this time depth conversion thing, and they're going to be called horizons_TWT. And there's 4 of them, and I numbered them from deepest to shallowest, but let's just go pick them. Okay, so there they are. These weights you saw, those are the weights that David used the other day for fault interpretation.
For now it's one, let's get to one.
And then we can look at one of these guys by view the first surface format. Oh, I got to look at it again. Okay. Horizons in time.
Because we organize, like, have different demos, organize everything, but usually you have your own directory work, so you don't have all these going.
Okay. So here's what this format looks like. It might have been exported by Charisma. It was exported by somebody at Statoil. Okay, so who knows what software they use? You know, there's what? 8 million Norwegians and probably 12 million Norwegian software packages or something. So notice that their inline and crossline number are floating points. This is the kind of headache that folks like me and Anik run into. Well, you're reading a floating point number, well, even though you think it's a floating point number, that's a real number, it rounds stuff off. Stuff off.
Well, yeah, because you can have this act.
Oh, there could be a number that I don't see.
Like,
Yeah.
right, so you can write an ASCII number down.
Yeah.
That isn't exactly representable.
Oh, that's common for fractions. Yeah. So these look like integers, but they're not. Okay.
And yeah.
So anyhow, so we're gonna do like Bo did before, and so that's what this looks like. And I'm going to go up, and we are using under here interpolated inline crossline because that's what the folks there did. A new pop-up shows up. I happen to have 58 header lines. I just had a look at it. I have 5 columns, and they're in 1, 2, and 5. Okay. And that's what those look like. Okay, I had 58 on the top. Okay. And I go back. I've got everything defined, I think. Millisecond, second. Let's see if it works. Okay, it's going to still thinks it's undefined. So there's something I have to reset. Second, I'm going to reset the millisecond. David and I will figure that out. Okay. Okay, it's going to multiply by 001. Fine, done. Okay, so I've got 4 volumes there. Now, we've got to repeat the process. And let's see who's, we got people walking around helping you helping.
Yeah, like.
Okay, in case they're lost. So, I mean, this is tedious, but this is what it's all, this is probably how you spend most of your day. Tedious stuff, right? Okay. And if you got another wacko format, so like Amanda at Devon, she had some wacko format. She brings things into R and ANOVA and comes out with surfaces that are really weird format. We can figure it out. We'll figure it out. Okay. Hopefully half of you were there. We got helpers walking around. We're gonna redo it. Everybody kind of up there, okay? And in fact, maybe what we'll do here, let's do this. I'm gonna put my horizon I'm gonna load my seismic, why not? And I have time to depth serve, time, darn it. AASPI time to depth, oh, here I am. Why am I here? F3, I don't know why F3 is there. Day 2.
Oh, this is not.
Damn demo time. Oh, yeah, I'm in the wrong. I gotta go to time to depth conversion.
I didn't need to go back to the other.
There's my data. And I'm gonna define that. And here's my data. Got it upside down. Then I'm gonna have horizons. Gonna load horizons. They're going to be time surfaces in seconds. I got 4 of them. Gonna choose them all. Open. Then I'm gonna display them.
Hey.
Okay. So here we got the surfaces in there, okay?
Yeah.
So if you don't like the surface, they were picked by somebody at Stotaway. Okay, so you might get something like that, okay? Now,
Well, I think they're probably ended up, because I didn't restart it.
let me go back to,
They're gonna end up at Sam. Yeah.
so this is what we did in readable form. I started out, went into get the conversion program. The top part, I entered the seismic data, how I want, what the units are on the input, what I want to convert them to. It fills out the output directory. And then I had to go, I highlighted this thing. I picked my 4 horizons. And then I had to worry about the format. So it had to be, I had to skip the first 58 lines and I went to 5, 1, 2, 5. And it has to be the Kingdom Suite, geomodeling, this is maybe Charisma, one of those. You know,
So you mean when I started,
yeah.
That's it.
No, if it says 001, that's what's nice. Making sure it's
Oh, the load here. I see.
Yeah. Oh, you already.
That's like a big deal. No, I gave it to you.
Circle that.
The horizons are under a file called AASPI Yeah, it's still.
Next thing.
So like it's only there's a lot of fans.
No, number 2. So we have one decided today.
This is the size. So I named the file different So that you knew what units it was. Because guess what? I have nine horizons, the fifth horizon, and there goes like the Shetland formation and the hot formation. Okay. Now, we're gonna do the same thing for depth. And there's really only one difference in depth. We're gonna use the, and then I say, yeah, it's a good idea to quality control your surfaces. So many of you did that already. Okay. Then we're going to repeat the process for depth. We're going to use the same seismic horizon. And now the difference when we bring in our data, are we seeing it? Yeah, we're seeing it. Good. Our reference seismic data is in seconds because that's what we got. We got pre-stacked time migrated data. Then our input geostat horizons are in meters from Charisma, whatever. And then what we want to output them is in kilometers. So you see, we got three different units here now. Okay. So we're going to do that. So we're going to put in meters, kilometers, and the input data, we can't change it. So what it's reading from the input data are the X, Y, inline, crossline. That's what it's reading, the size of the survey. If your horizon is much bigger than this piece of the survey, which it is here, it's going to crop it to be just overlapping the survey. Okay.
Yeah.
Okay. Okay. George, can you help them? We're trying to follow. Okay. So in this, okay, I will then go back here. I'll minimize this. Okay. I am in surface input. I am going to surface import. I've got the same reference horizon, which is D, MIG, Bordeaux. Okay, 101 by 1 or 201 by 201. Then I've got a Z-null in mapping. Z-null means it's not a point. So a common one is minus 999.25. That's just a common one, okay? From the people who wrote all, the same people wrote all the mapping software.
Yeah.
The ZMap people
Yes.
wrote it all.
Yes.
They wrote it for everybody. Quit, start another company, rewrote it. Okay, so the input units of the surface now are going to be in meters because they're the depth data. The output surface I want to be in kilometers. And then I need my output directory is going to have a similar name, but it's going to be AASPI surfaces, depth surfaces in kilometers. That way you can keep it in your head, straight in your head.
We are seeing your presentation now.
You can't see it?
No, we are seeing the presentation, not the software.
Oh, well, do your magic. Here, hang on. Are you the me? I don't know why.
No?
Okay. Yeah, there we are. I think. Okay, but
Can you press H?
H. You need 3 fingers?
Yes. 4.
Okay. Floating meeting controls. Okay, whatever that is. All right, now I've got to bring in, I can go back, I can reset the list of horizons. I'm going to go into a directory called up. Got to go up, and they're going to be called horizons_depth. And those are the ones, again, that came from Statoil. Okay, but they were converted to depth using geostatistics or whatever. And I've made the name simple so it's easy to understand which one's high and low because you guys don't work the North Sea, or most of you don't.
So the base is above the top.
The base is at the bottom, so I'm numbering like a geologist where we started ancient time and whatnot.
Gotcha, all right.
But you know, that you might have different styles in different companies.
Yeah.
Okay?
Yeah.
Just like, hey, red is good for low value, shallow, and then velocity analysis, red is
Yeah.
hot for
Yeah.
high value.
Yeah.
So, you know.
Yeah.
So, okay, so I got those. Now the format is going to be the SciX format. Going to be very, very similar, okay? But I need to change it just one thing. For whatever reason, the header data has 59 header locations, okay? And how do you do that? Well, you look at the simplest thing. I use VI and Linux because I'm a Linux person. But you just bring up your happy editor and you put the number of lines, and you say, okay, that's it. I mean, that's the foolproof way.
Does the automatically detect header not work?
Where's David?
Try it.
No,
I tried it and it did not work.
No, okay.
I didn't write that.
I'm just wondering what.
Me neither. I didn't write. I was fine. So.
Yeah, I'm scared of it. Okay, I don't know what it's looking for. It's very complicated.
No,
All right. So then, that should be good. I'm gonna just execute. Hopefully it works. I'm gonna multiply by 001 again. And it says it worked.
Okay, one thing, with the 3D, if you want to find the surfaces in depth, it's not gonna match. They're gonna plot, but it's not gonna match. It's because in the 3D, there is no coordinate system. I mentioned that.
Then I was gonna skip that part.
It's okay. Just, it's because they are loading the horizon, so just
Yeah.
caution. So
Yeah,
the
so-
XY is XYZ, but we don't have a coordinate system. So everything is like in number of inland, number of crossline, number of time samples. So definitely the time and the number of samples, because the sampling interval is different, doesn't make match. So I'm gonna put some more control there.
No,
I
it's
probably,
a two-line fix. Here's the issue. We don't have any depth data, so we don't have a depth reference. And we don't know how high and how deep, how shallow and how deep to make it until we've brought in all the horizons in depth, which we haven't done yet. So you gotta, it's not a difficult thing.
no, it's not difficult. One thing that I'm gonna put as a toggle, time and depth. You know, like, well, a lot of interpretation packages that have that.
Okay. All right. So we can, oh, now, David, are you saying I cannot?
You can plot it, but it's not gonna match the position.
No, it's not. So I'm just gonna take off the seismic as well.
Yeah, so
Okay.
one thing, if you want to match it with the register, open right now, go to visualization,
Yeah,
go to single volume,
single
and then
volume,
go in single volume 3D.
3D, right? So you get the same
keep
thing.
that one for the depth, okay? That's like a fresh start with the correct sampling. So you can have like two windows right now, one in time, one in depth, and it's gonna work.
Okay,
with the-
okay, yeah,
with the
yeah,
phone.
yeah, yeah. So I'm just gonna load those 4 horizons just so you can see that they did get loaded. Okay, so go to Horizon,
Yes.
load horizons. It's going to be under this directory called AASPI depth surfaces in kilometer. Okay, so I'm trying to be real explicit as to what they are. I'm gonna pick them, all 4 of them. It doesn't matter the order right now. Open it, and then I have to put a check mark in front. And there they are, okay? So those are the depth horizons, okay? So they're just horizons, okay? So hopefully we got there. Is everybody kind of there?
Yeah.
All right. Okay, now the next thing we're going to convert to, we're going to take our depth volume and our time volume, convert it to depth. So we are going to go under data conditioning on the main menu. Okay, so it's under data conditioning and drop down, convert from time to depth. Now, the same program we call from 3 or 4 places in the pre-stack data, then we do this AVAZ and stuff like that. But here it's the same program, okay? So you convert from time to depth, everybody kind of sort of there. And it's got its own, sorry,
So one comment, there are a lot of outputs that are in the SAM demo. Remember that in ASPI, you select what folder you want to work in. You selected SAM in the previous demo, and we didn't restart ASPI. So remember that we're having several projects at the same time. That's not
You have to
usually
go
the case.
up and down, right?
So yeah, you just go, if you don't see an output is in the day 2 SAM demo, you will see all the outputs there.
Okay, so here is the surface-driven registration GUI, and let me just go over it a bit in the PowerPoint. Go through, blah, blah.
It's kilometers, right? The output?
Yeah, the output's in kilometers. And the first thing we're gonna do. We're gonna bring in time and depth horizons. So if you drop down on this GUI, here's where I am on the GUI. Hopefully that GUI came up for you. All right. Okay, is the GUI showing, Corey?
I kind of got
Okay,
behind on everything.
Oh.
But I can't try that.
okay. We're gonna help.
It came up.
It's under
I got it.
data conditioning.
Yeah.
Okay. All right. So now let's go to the hard part first. In the top, it says here, these are, oh, let me go up here. I'm going to bring in my data set, D, MIG, Volve, and it's under time to depth conversions and ML. Okay, so that's where it is. Okay. Give it any suffix you want. So that's my time volume. Then the undefined, okay. I've got to enter my, I'm wondering why it's doing this wrong. Hang on. I don't know why that's, okay. Let's go. Oh, here it is. Here it says the input vertical axis is in seconds. So I go to time surfaces in seconds. Now this is where it gets a little tricky. I am going to, if I click this guy on the right, it puts a name, and I'm going to sort them so that number 1's on the bottom and number 4's on the top. Because guess what? These guys have to have the same number of horizons and in the same order because they map 1 to 1.
Can you order them with the minimum of each horizons, the maximum of each horizon? You can do it automatically. From the .h, if you know the mean of each
Yeah,
horizon, you
okay,
can
we'll
sort
think about that. We'll think about that. Today, what I did, I put the number 1, 2, 3, and 4 in front. Okay. Yeah. Okay. So we've got those, and they're in from 1 on the bottom, 4 on the top. I'm going to pick them all. If you don't have them in order, you got to pick them in order 1 at a time. Okay. So there we are. Okay. That's in time. Then I want to do the same thing in depth. And this is going to be AASPI depth surfaces in kilometers. I'm going to change the order. So 1 is on the bottom. I get that. Okay. And now, here, my output vertical axis is going to be in depth and it's going to be in kilometers. Okay. And now the start time in depth, well, what is it? It has those 4 horizons. I'm going to scan them. The 4 horizons range from about 2.5 to about 3.5. I'm going to make it a little bit above, a little below. I'm going to put in 2.5. He says 2.5. It's not a point. 2.5. 3.5. Okay. I'm good. So I got that. And if I just hit execute, it's going to hate it because the default increment is 0. So we're going to pick in something reasonable, a reasonable one, 5 meters. If you're Corey, he migrates at 5 meter increment, right? Brazil, real common.
If you.
10 meters is common, 30.
It depends on how much money you have.
Yep, that's right. Okay, so we're gonna put in here, it doesn't really matter, it has to be a reasonable number. I'm gonna put in 005, which is 5 meters, so 005 kilometers. So you should be there. Okay? Everybody kind of sort of there?
I was there, but I didn't get this. But I'm following along otherwise.
No.
Lost, where's that one? Perdido, I know that one. I learned that one. There's a lot to hold up. Yeah.
They use that.
Ah,
This is my stand. Can you show the window?
yeah, thinking. It's bright-ish.
Okay.
This is.
Global mapping. Here's the thing, this is the one that's like. Those places I've stumbled on.
Yeah, I mean, he's a lot of. I could work. So this is.
This should be down there.
Okay, so if you've gotten that far.
There is an error in Fortran. There is an error running Fortran. The bright doesn't bright. It's a Windows Linux issue. Let me just double check.
They ran it over on that machine, mine.
Yeah? Okay, I know why it might be.
So, don't worry about the writer.
Yeah, I'm fixing it.
Ignore that man behind the curtain. The Fort 99 thing, when the program exits,
To try to write.
I say normal completion.
Does it try to write
If you
that?
write it from the slave,
It tries to write it.
it tries to write it someplace.
Yeah.
So I fixed it last night, but I didn't want to bother you again.
I compiled this morning.
Didn't know that. Anyway, so everything's fine. So now
Oh,
let's
okay.
go compile, let's go plot.
Everything is fine. Don't worry about the Fortran error.
Don't worry about it. Ignore that man behind the curtain.
I was just.
Seismic.
basically Trying to patch standard out back. File.
Now, the data file is called registered underscore demigration. So it's a registered file, okay? I guess I should put the name depth in there, but I didn't. And we'll open it. And then put a click in front of it. And there's the data converted to depth. Now, you'll notice there's some blank spaces. That's because the horizons didn't go that deep. And then if I look at other parts, it's clipped. Oh, no, the input data were clipped. That's what happened.
I don't, so what I'm using the triangles to match corresponding line surfaces in depth.
Yep.
And that's why you build your time depth earlier.
Perfect. Nothing wrong with that. I mean, this is where, if you're working the resource way, they have to get a demo.
Yeah.
Well, they need to do horizon. Okay. Okay, so if you have it converted to depth, we have. See you, sir. You should go in today.
I did indeed, yeah.
You didn't go via Seattle and it's infected.
Oh, I did not. I did not realize. I did not realize that. Yeah, it's. The way ignore this termination.
See if you can plot that side.
Let me see if I spawned out.
So here's your last time.
I was going to do DD.
Oh, this is okay, okay. So there's the connection. Don't worry about that. I think it's not.
Screwed up, watch that.
So, yeah, sure. Okay. So, no, the reason, that's okay. That is a known feature. This is not okay. I could have fixed it last night, but I know details. Other one, I'll bring it in. I don't like shit. I'm gonna hit the more insane.
So let it go. Okay. All right.
So we know, what it has the.
Yeah.
No, let me explain how to, okay, if you follow me real quick, I'm gonna explain it, it's something really quick to fix. So what happened is, I know you want to show your seismic in depth, so remember you have a time and a depth window, okay? So what happened is
You
this,
can't put an axis on.
yes,
No, not yet.
no,
Okay, that's all right.
a good feature to have. So you see the surface in depth. One thing that we have in this, oh no, don't open us.
You know. You don't
Okay.
want to show them how to edit it by hand, do you?
Yeah, let's do that really quick.
Okay, just
So-
demo it, just demo
So,
it.
yeah, so if you don't want to follow, that's okay. But the thing here is like, I go to the surfaces in depth, okay? I go to the dot H, and I'm gonna edit the dot H. So,
Bottom.
yeah, so, okay.
Hold on, of course, I-
So you see here, this little seismic init is initial time. It's using the seismic in time, not in depth. For a reason, it doesn't match. So we just found out yesterday. So we just need to rewrite with the correct. So the corrects are actually 2.5 and 0.5. That's it. And then if you do it that for all the surfaces, let me show you. Let me show you one. You go to surface 1. And that's it. You see? It's because of it needs to know what is the correct initial time of the seismic and the sampling interval. It's using the seismic in time, not the seismic in depth, but we'll figure it out. It should be an easy
I mean,
fix.
this is group programming. I mean, you have different people from 6 different countries documenting things 6 different ways and then merging it all together. And this is what happens. Okay, but okay. I'm just going to show the last picture. Okay, so the last picture is simple. We're going to accept that you got to go through artificial intelligence, multi-attribute machine learning. You could pick unsupervised or supervised, doesn't matter. Generate training data. Here we talked about polygons earlier, okay, and extract point sets from the polygons. Surfaces, David showed that yesterday for faults, made point sets. We are going to go here, well control option, define point sets around the well, okay? And then Anik will put his point sets from SAM, okay? So there's the program. We've got a couple of wells. We've got 2 wells, and it's called, I got to go to day 2. Here, this one. It's going to be well data, and there's 2 wells, F12, F15B. Okay. I can show you what's in those files, but let's not for the moment. I've got a Oh, crap, forgot one other thing. Seismic attributes, geometric attributes, dip attributes, GST and semblance dip. Take our depth data, the registered data, use all the defaults, hit click, okay? So it's going to take that depth migrated data, it's going to now have dip and depth, okay?
Put cancel.
Why?
You have this window. Just put cancel if you see that.
Oh, okay, yeah. It thinks that I'm hacking into my own computer. Because it's running MPI. You do that once. You only have to do it once. But, and not just once per day, once like ever. Okay. All right. So, so there's a depth data, inline, crossline, dip. So now I go back to this program. I can minimize that. And define point sets. Down here, pick the inline dip, crossline dip. Don't worry about parallelization. I'll just leave a default radius of 125 meters. We'll have to figure out what good defaults are. And then we're gonna execute it. Except I gotta move it up. Execute it. And it runs really fast. Okay, now, most of the facies information is outside of the crop volume that you are getting. Okay, so it's going to show, okay, nothing found, nothing found, nothing found. But what you do if you go to the directory where the data are, and so it's probably in this one, David? Nope.
No, we see the day two.
Day two.
And it's here. So just date modified.
Date modified.
Go up. Oh, it should be around. What are you looking for? What is the name?
It'll be the name of the facies with the files. Registered data, Oh, here we are. So in my case, they're called like facies claystone, facies claystone to shale, facies sandstone wet, sandstone, facies silty sandstone, facies unconsolidated quaternary stuff. And in your case, facies 1 carload, facies 2 carloads.
That's what we just created.
Yeah. Yeah, the facies file is there in that little.
Yeah, it should be in day
LAS
two.
generator.
Inside day two. That's where you open.
Yeah, it starts with the letter F. That's how you're going to find it. And then if I look at the one that is got a lot of stuff in it, I'll look at the oil, and I'm going to open it up in Notepad. Thank you. And it's just going to be depth, second column, CDP number, line number, and it goes down all those voxels. I mean, it's as simple as that. That goes into the machine learning, whether you're using random forest decision trees, GMM, CPM, anything, PCA. So that's it. So let me just end this with one PowerPoint thing. I'll email the PowerPoint out and add stuff. Or I'm going to give it to Heather and she will do however she wants to get it. I want my PowerPoint up again. I can't see data dually. Okay. So the next steps then. The simplest, we need to determine the simplest way to convert alternative facies logs into something this program can use. I use Excel a lot.
Yeah.
But Georgini says, yeah, the LAS files and open, that's a real common one.
LAS is that.
I mean, and where you have measured depth, relative XY, relative.
Yeah.
Y
So
relative,
you end up.
true vertical depth,
Yeah.
and then the faces name, I can figure that out.
Yeah. You usually have option of having all of the coordinates or an LAS file paired with them.
Yeah.
But that's probably more.
So there's two files, that's the problem, there's at least two files.
Yeah, but,
Okay,
but
so then-
you might actually look and see if there's any LAS readers in Python already.
Oh, we can read LAS, yeah.
Yeah.
So the other thing I need from Georgiades again, and then maybe from Stephanie, if she's still here. I need now for perforations the stage number for each well. And I think the simplest way to do it is to have, what's the measurement you want from your well? Is it breakdown pressure? Is it carloads of sand? So then if I have the XYZs and it says, okay, it's this bin of carloads of sands, that's my phases and I can read that in. But some thought has to be given as to how to do it. Because your perforations are gonna be XYZ, right? And then we need to assign a faces to it. Like, ooh, good part of the well, bad part of the well, whatever you want. And from there we can go on. Or flow capacity, that kind of thing. Then, okay, then the other thing I have to work with the machine learning with the GTM and self-organizing maps. Okay, lunchtime. When we come back up later, I can help anybody who's got stuck. And anyhow, we're almost there. We're almost there. Okay.
So it's all set up downstairs, first floor, same place as before. We got barbecue. Yeah, and then we'll go maybe until, we'll do lunch until about 1 or so. You'll hear me yelling at you in my mom voice. I'm not back upstairs. But yeah, head on down and we'll have lunch and
we would send them, we can send them the little data sets that we're using, right?
yeah, I think all the data sets that are public, I'm gonna double check. Yeah.
Okay. But, so you guys. And the interpretive horizon.
We can lab track at the Helmy's office.